angles of triangle. We're going to be actually talking about triangles a lot. So we're going to define for you what a triangle is. Does anybody know how we're going to define a triangle? It's sort of something that we already know. It's sort of hard. Yeah, what do you think? It's going to have three sides. Okay, so yeah, we're going to actually define a little bit more here. They're going to say it like this. Yes, a triangle is a figure formed by three segments joining three collinear points. Okay, that's the definition of a triangle. And you're right. Each of these joint segments are the size. They tell you right here. The segments are the size, right? You're right. And then, but that's not included in the definition, is it? And each of the 3 point is the vertex. And what's the plural for vertex, guys? Vertices. Very good. Does that make sense? So write that down. So the definition of a triangle is just up to here, right?
Write each of the three.
Yeah, but then you have to know what the definition of a vertex of a triangle is, and then the size of a triangle is. So that's what I want you to be aware of. I'll wait. So here's a picture of a triangle. You all know. You've seen a triangle. No, you don't have to draw this one. You know that it has three vertices, ABC, right? Oh, by the way, there's a symbol for triangle. So if you want, you could use that symbol to indicate a triangle. Notice how they do triangle ABC like this, okay? And then you have the three sides, the segment AB, BC, and CA, and then you have three angles. Okay? So we're going to talk about these triangles. Now we could actually classify the triangles by their size. And you might know what we call the triangle with all three sides different. Like let's say you have a triangle and all the sides of a triangle, right? The measurement, the distance, the length of the sides are all different. What do we call this triangle? How about Kevin? Scaling triangle is correct. Very good. What about, so here's scaling triangle. No congruent sides, right? That's okay. You all know what. Okay. Now, what about a triangle with all three sides that are all congruent? What do we call that triangle? How about Grace? Equilateral triangle is correct. Very good. So here. All sides are congruent. Now, then what's the one that's left? Yes, isosceles. Now, who thinks they know? This is sort of tricky because many people have the wrong definition of an isosceles triangle. Who knows the definition of an isosceles triangle? Okay, so like I said, it's not okay. So it's a bit tricky here. Eric, what do you think? Two of the sides are congruent. That's what a lot of people think, but actually you gotta. There's actually something more to that. It's not that two sides are congruent in a triangle. It's actually the definition actually says. How about John?
At least two sides.
At least two sides. So I would actually write this one down. I mean, you know the scaling and the equilateral. Write this one. It says at least two. Okay, it does not say two sides. Hold on to that. Hold on. So write this down first, and I'm going to ask that exact same question. Very good. Okay, hold on. Write that down. All right. So isosceles triangle. Why is it important to notice that it says at least two, not just two? Jason? Yeah. It turns out an equilateral triangle is also an isosceles triangle. You could actually.
No.
Yeah. Say that. Yeah. But is this true? Can I say this? An isosceles triangle is an equilateral triangle? No, not always, right? It is sometimes, isn't it? You know what I'm talking about?
Equilateral triangle is always.
Yeah, equilateral triangle is always an isosceles triangle. But an isosceles triangle is sometimes an equilateral, right? Does that make sense? Because it says at least two, right? Do you see the difference? Okay, any question? Do you see why I want you to write that down? At least two? Okay, good. Now, if we could, not only can we classify the triangles by their size, but we could also classify these triangles by their angle measure. So if all the angles of a triangle is an acute angle, okay? If all three angles are acute, can anybody know what that triangle is called? Everybody? Oh, not too many of you do. If we have a triangle, right, and all three angles are an acute angle, what's an acute angle? Angle that is?
Less than 90.
Less than between 0 and 90, right? So what kind of triangle is this if all angles are acute? Nicholas? Not quite sure? Pomon, can you help him out? It's an acute triangle. Yeah, so it's not there. Yeah. If the angle is an acute, oh, thank you. If it if all three angles are an acute angle, it's an acute triangle. What? Yeah, if you didn't know that, when I ask you, you should write it down. Okay, you should. Okay. Now, what about one of the angle is an obtuse angle? Nicholas, you want to guess what this is called? Yeah, it's an obtuse triangle. Okay, very good. All right. So if one of the one angle. Okay. By the way, can I have more than one angle to be obtuse in a triangle? It's impossible, right? It's not. They're not gonna. It's not gonna be a triangle. What if one of the angle is a right angle? Tony. It's a right triangle. Exactly right. Now, what about all angles are congruent? Anybody know what the name of this triangle is? How about Young? That's exactly right. Equiangular. Does that make sense? So if you didn't know any of these, go ahead and write it down. I'll give you time. If you knew them, that's fine. You know them. Okay. But if you didn't know them, go ahead and write it down so that you know what they mean. Okay. I'll wait. Who wants to read for us what this says? An auxiliary line is a line. What? Anybody want to read? Yes, go ahead. Yes, John?
Auxiliary line
Uh-huh.
is a line or ray or segment
Uh-huh.
added to a diagram to help it.
Yeah, it's added to a diagram to help us to do a proof. Okay. Turns out this next theorem that we're going to talk about. Okay. Do you think it's gonna? If you like, yeah, that's up to you. I'll give you. So if you like to write this down, this is the next proof that we're going to be doing. Do you think it's going to use an auxiliary line? Yeah. Okay. Now, actually, this proof that we're going to be doing is one of the famous proofs in geometry. A lot of you know this as a fact. How many people know what the measure, sum of the measure of a triangle is? The sum of the measure of each angle of a triangle is? Yeah. Everybody? 180. It's actually a?
Straight angle.
Well, it's actually a theorem. So it's not a fact. So what do we do with the theorem? We prove it. And here is the auxiliary line that's going to help us to prove this theorem. You see this dotted line right up here? Okay. And I'm going to show you. So this is us. This is actually the first time us seeing an auxiliary line, right? So we're going to show you how to actually use this line to prove. Okay. Actually, let's just follow along. It's in the book. I want you to understand this one. Okay. So that's fine.
Just write the theorem, right?
Yeah, just write the theorem once. Exactly. Yeah, I'll give you time. So how are we going to draw this line, right? That's one of the questions. You don't just randomly draw any line. Okay, this line is drawn. Here, let me show you. In the proof, okay, I'm going to say statement through B, draw line BD parallel to line AC. Okay, and that's what that BD, line BD is. By the way, what allows us to do this? Because you can't just draw any random line. You have to have some sort of reasons for it. Can somebody now think back to what we did last time? Who remembers what might be the reason? What allows us to draw this line BD? Let's see who remembers from last time. You could even look at the notes from last time. Samantha, what do you think? This is sort of like the construction, isn't that right? And what allows us to do that construction also? Thinking back to theorem, one of the theorem we talked about actually last time. Do you remember? Yeah, you had your hand up. What's the reason for this? Definitely no, it's not, because the auxiliary line doesn't tell us that it's going to be parallel to one of them, right? So in order to draw an auxiliary line, what I'm trying to say is you have to have a reason for it. Like I said, you could go back to your notes if you like. But Samantha is correct, right? We did this construction, didn't we? Didn't we draw a parallel line through a, right? Remember we had a line and a point outside the line, we drew a parallel line through that? But remember, what theorem actually tells us that there is a line that we could draw something like this? John?
Through a point outside a line, there's exactly one line parallel to the given line.
That's right. Because of that, we are able to draw this. You guys remember this from last time? Through a point, this is one of the theorems that we talked about yesterday. Through a point outside a line, there is exactly one line parallel to a given line. You guys remember that? Go back to your notes. It's there if you wrote it down. At the last part. Just go back to your notes. It was one of those three theorems that we talked about. No. Look at the theorem. Go ahead. Go take a look. If you don't believe me, go back to your notes. If you have your book, it's on page 85. Okay, we talked about this.
Oh wait, I see it.
Thank you. At least one person agrees here. Remember, we talked about this along with through a point outside the line. Not only is there exactly one parallel line, but there's also what? Yes, sir. One perpendicular line. Remember that? Okay. Yeah. Sorry, I said you didn't have to write that one, but we're using it now. But we talked about this last time, didn't we? Okay. Now this is the reason why we could draw the line BD, right? Because there exists a line, right? Exactly one line, as a matter of fact, that passes through B that is going to be parallel to AC. Is that okay? Now, how is that going to help us prove this? That's the key. So why do they even, draw this auxiliary lines? How is this going to help us? Oh, a lot of you see it. And you know what? I want you to discuss with your group. Let me give you a hint, by the way. When they give you these angle measures, hello, you see we have angle 1, 2, 3, 4, 5. That's a hint. You're going to be using those. Okay, go ahead. I'll give you time. Here we go. Let me ask you this. After this, how are we going to show that angle 1, 2, 3, some of the measures of angle 1, 2, 3 is equal to 180? First of all, like I said before, whenever they give you these diagrams and they give you they number these angles, and you're going to be using these, okay? So anybody know what to do? All right, 1, 2, 3, 4. Nicholas, what do you think?
You have to angle 1 and 4.
Oh, really? He's exactly right. Why is angle 1 and 4 congruent? Because that's the key step of the proof. You're right. Why? Does anybody see why? Andrew? They're alternate interior angles, but you're right. You have to say something. Because these are alternate interior angles, because you have, what kind of lines are these? These are? Good. I mean, if you just say alternate interior angles are congruent, is that a true statement? No. Not all alternate interior angles are congruent. When are they congruent? When you have two parallel lines cut by a transversal. Very good. And isn't that why we drew DB? Because we drew DB so that it is parallel to AC. That's really important. Otherwise, it won't work. So you're right. Angle 1 and 4 are congruent. Which other angles are congruent then? Grace? No, we know that 1 and 4 are the alternate interior angles, right? Are there any other alternate interior angles? Okay. So think about this. Look at BC as the transversal. Yeah, 3 and 5. Does that make sense? So if you look at AB as the transversal, you could see that 4 and 1 are alternate interior angles. They're congruent. If you look at BC as the transversal, then you know that angle 5 and 3 are congruent. Is that okay?
Wait, can there be two transversals?
Right now we have two, right? In terms of these two parallel lines, there's one transversal AB and another one, BC.
But then how do you get corresponding?
Did we talk about any corresponding angles so far? We're talking about only alternate interior angles right now. Okay, now, so how does it help us to prove this? One person see it? So what? That's great to know. Okay, we know that angle 1 and 4 are congruent. Angle 5 and 3 are congruent. So what? Okay. Who haven't I called? Okay, Brianna, what do you think?
1 and 4 are congruent measures, and 5 and 3 are congruent, and then angle 4, 2, and 5, they're
Yeah, look at angle 4, 2, and 5. What do you get if you were to add up angle 4, measure angle 4, plus measure angle 2, plus measure angle 5? It's 180. So now you could plug it back in, right? And prove. Does that make sense? So, very good. That's how you go about proving it. Do you understand? Right, I'll show you in a minute. So, look, do you all agree that 4 plus 2 plus 5, measure of those three angles, it adds up to 180? Now, how are we going to do this using deductive reasoning? That's now the key. Because we know why this is 180, right? How you go about proving it. How do we do this in logical sequence? What should we do next? Samantha?
We should say that angle 1 is congruent to angle 4 and angle 3 is congruent to angle 5.
Sure, let's say we did that. Actually, they didn't put that here. That you could have done that already, but they didn't do that one first. But it's okay. And then what? You're right. That's one of the steps.
And then angle 4, or the measurement of angle 4 plus the measurement of angle 2 plus the measurement of angle 5 equals 180.
And what would your reason be? That's what a lot of people will do. Can we say at this point, measurement angle 4 plus 2 plus 5 equals 180? And what would your reason be? Angle adjacent postulate, which part? The second part. But if you go back to your angle adjacent postulate second part, how many angles do we add? 2. We didn't add 3, did we? Because remember, this is how we constructed it. Remember, we had a straight angle, and we put a point outside of that straight angle, and then drew a ray, and then we added those two angles together, and that added up to 180, right? So I know that in our minds, it's so obvious. Of course, all three angles add up together is 180. But if in order to use that angle addition postulate, we have to sort of make it into two angles. Is there a way to do that? And then sort of, yes, Jason? Yeah, let's just go with DBC first. Angle DBC plus angle 5 is equal to 180. That you could say as what? Then the reason is
The
angle addition postulate. Is that okay? But we don't want to keep it as DBC, do we? But what is DBC made up of? Yeah, so could we say angle 4 plus angle 2 is equal to? DBC. And what's the reason for that? Which part? The first part. So notice what they do here. They just, as a second step, they write DBC plus angle 5 is 180 because it's the angle addition postulate second part. And then DBC is equal to angle 4 plus angle 3. Does that make sense? And guess what we want to say next? Now, why do we do all this work for, okay? Why do we do all this work for? Because we want to say what we initially said. What is it that we want to say now? How about Josh? Exactly. All three now, we could now say all three angles equals to 180. What's the reason? Andrew, what's the reason? Now, why do we do all this work? What's the reason for the third step now? Substitution is exactly right. Does that make sense, guys? Do you see how we can't just go to the third line straight? You see, okay, so I want you to kind of, look at that, okay? Because remember, angle addition postulate just adds two angles at a time. Right? You can't. I mean, in our mind, of course, obvious, right? All three of these angles, 4, 2, 5, right? It adds up to 180. But you have to say it this way. Do you see what I mean by deductive reasoning, right? You have to do this in logical sequence. Next, what can we do next? We're almost done, and this is what one of us said already. What are we going to say next here? One person see it? 2, 3? Who haven't I called? How about Jonathan? What do we say next?
I wasn't sure.
Okay, so Jonathan, we have angle 4 plus 2 plus 5 is 180, right? Instead of 4 and 5, what do we want? We want angle 1 and plus 2 plus 3, right? So how are we going to do that? You have to say something about? So we have to say something about angle 1, don't we?
Oh, that angle 4 and angle 1 and angle 3 and angle 5.
Are what? Congruent. Isn't that what we want to say?
Yeah.
Why? Why are they congruent? Hold on. Why are they congruent? Let's see if you...
Alternate theory.
Yeah, you have to say the whole thing. You can't just say alternate triangles are congruent because that's not true every time. What do you have to say? If two lines are... Yeah, exactly. Then...
Alternate interior angles are...
Exactly. Do you guys see this? Okay. Does that make sense? Then, now we're ready to substitute. In place of angle 5, in place of angle 4, what are you going to plug in? 1. By the way, and instead of angle 5, what do we need to plug in? 3. And there it is. It's because of substitution property, right? And notice, look, they should have put one more step from congruence to measurement, right? Remember I told you it should just kind of, they should put one more step. What would the reason be if they go from congruent to the measurement of angle 4 equal to measurement angle 1? Yeah. Definition of congruent angles. Does that make sense? But they didn't. They skipped that part. But do you understand the reason how we go about proving this?
Yeah.
Could you do this by yourself if I ask you to prove
Yes.
why the sum of the angles of a triangle is 180?
Yes.
Okay, you're going to draw this auxiliary line and then add these three angles up. But we know that angle 4 is congruent to angle 1, 5 is congruent to angle 3 because these are alternate. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Does that make sense? Any question? Are we good? Now, from this theorem, there are some other statements that we could actually say. Okay, so let me get to the next one now. Who wants to read for us what this? Yeah, go ahead. What this says? Yeah, Michael.
Write it?
No, you don't need to write it.
A statement that can be proved easily by applying the theorem is often called a corollary of the theorem.
Yeah.
Corollaries, like theorems, can be used as
Reasons for in proofs. Does that make sense? So these are some of the statements that comes from this theorem that we just proved. Okay, let's see what we could say, okay, by using this theorem. It says this. You don't have to write this down. Let's just see if it makes sense, okay? Because we're running out of time. I would have had you written this down, write this down, but we're running out of time. So, but you could use this for your homework tonight, okay? Or tomorrow.
Postulates, theories, and corollaries.
Right. But these corollaries comes from the previous theorem. Let's see why. Okay. Can we understand what this says? If two angles of one triangle are congruent, of two angles of another triangle, then guess what?
Third angle.
Third angles are congruent. What does that mean?
That makes sense.
Does it make sense?
Oh, I know.
Does this make sense? Think about this. Like I said, don't write this down because we're running out of time. I want you to understand these corollaries.
Yeah.
What's it mean? If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. What does it mean? Who could explain? By the way, how many triangles are we talking about here?
Two.
There are two. Okay, what do you know about these two triangles? Who could help us here? Naomi, does this make sense? Can you explain? Not quite? Okay, let me actually, hold on. Let me just, if I draw this, it'll be like, let's say I have two triangles, okay? A, B, C, D, E, F. If these two angles are congruent to these two angles in the other triangle, what can you tell me about angle C and angle F? They are? Yeah, they're congruent because why? Class, sum of the angles measure of a triangle is? Does that make sense? That's all he's saying. Nothing hard. Yeah, there are four of them. Hold on. So does this make sense?
Yes.
This is what he's saying. Look, if two angles of one triangle are congruent to two angles of another triangle, guess what? The third angle must be? Let's look at the second one. This is really easy. Each angle of an equiangular triangle is, of course, why? Because 180 divided by 360. And he says in a triangle, there can be at most one right angle or one obtuse angle. That's really obvious, right? Why not?
Because
Yeah, it'll be either 180 or more than 180 just by adding two of the angles. And lastly, an acute angle with right triangles are complementary. What does that mean? This one you might have to think about. By the way, if you have a right triangle, right? How many? You have two. What are the two other angles? These are acute, aren't they? So because there can only be one right angle. What do they mean by this? So let me draw. Hold on. Hold on. Yeah. If you have a right triangle, right? Hold on. Right. If I have a right triangle, what's angle A plus measurement angle B? It must be 90 because this is also 90, right? Measurement of angle A plus measurement angle B must equal to 90 because that's the right angle. That's what he's saying. Any question? Hold on. The acute angle of a right triangles are complementary. Do you understand? Yes. Any question? All right.